Okay, discrete math. Here we are, Mr. Mistakis, with another video lesson you're watching at home to get ready for doing Bernoulli experiments. This is part 2, where we talk about questions that involve at most and at least something. You'll remember, to say at most is the same as saying you can have up to that number. At least is the same thing as saying you must have that number or more. Okay, so these are multiple winners are going to be out there. Our first example is going to be done with a spinner, and this spinner is over here. There are 2 winners of the 5 evenly shaped segments. So when you hit this spinner, to win has a probability of 2 out of 5, and a losing or not winning is 3 out of 5. So that's what the spinner does for you. Here's the spinner, and you hit it and it spins around. And it'll never land on a line, we're saying. It always lands in an L or a W. And our first question, to give you an example here, is, okay, example 1. What is the probability that you get at least 3 wins in 6 spins? Now that's a horrible A there, so I'm going to fix this up. This can be seen to be a Bernoulli experiment because you either win or you don't win, and they're polar opposites, and they add up to 5/5. So this is a yes-no situation. Now, we focus here on the at least. This means with 6 spins, we know that n equals 6, okay? And your r must be at least 3. So, if you think about that, r equals 3, 4, 5, or 6. In other words, you can count up to there. It has to be at least 3 wins. Another way of saying that is that if there's 6 spins, you could have 3 wins and 3 losses. You could go up to 4 wins with 2 losses, 5 wins with 1 loss, or 6 wins with 0 losses. I actually like thinking this way because that's actually telling me the numbers I'll be using in my combinations. But this is perfectly okay as well. All right? Now, to answer this question, it becomes simply, I need the 4 winning probabilities, and I'm going to add them up. So I'm going to write this out for you then. Start with your first one. If I want to get exactly 3 wins out of 6, that's 6C3, and the winners go right there. That's that 3 always matches there. That's the way we remember the formula. This number is what's left. If I win 3 times, 6 minus 3 is 3. I lose 3 times. So, what were those probabilities? Well, it turns out winning, as you can see here, is 2 out of 5. And losing is 3 out of 5. That's one way this could work out, okay? We move on to the next one. But I also could win 4 times. And so the 4 goes there. And if we use all of our colors here, we get, oops, let's do the red next. If you're going to win 4 times out of 6, you got to lose. So that's the number of ways I could win 4 times winning 4, losing. And what goes in here? Again, 2/5 and 3/5. So as we work through this, what you realize is this is the same as day 1, part 1, but we're adding up different things. So I'm going to do the next group here. Still out of 6, there's 3 wins, 4 wins. Now we're trying 5 wins. So that's a 5. And we're also going to take a look at 6 wins. So that's a 6. So that's this 3, 4, 5, 6. You're doing exactly 3, exactly 4, exactly 5, and exactly 6. Using the formula over and over again. 6 minus 5 is 1. 6 minus 6 is 0. Those numbers, the blue and red exponents, can also be seen here. That's this idea. Okay, so let's put the greens in. That's 2/5, 3/5, 2/5, and 3/5. Now, when it comes to computing these on a calculator, your calculator is going to go decimal on you pretty heavily if you try to type them in the way you see them. What I like to do is instead to do the denominator, because first, separate. 5 to the third times 5 to the third is 5 to the sixth. 5 to the fifth and 5 to the first is also 5 to sixth. So all of the denominators are going to be 5 to the sixth. And that turns out to be 15625. So this first one can be computed on your calculator easier if you do this. Take these 5s to their exponents and think of them as done separately. What you type into a calculator is the remaining piece, 6c3, 2 to the third, and 3 to the third. This can be typed into a calculator easily, and it can get you the number you want. That's for the first one here. And so what you get when you type that in is, for this, you will get 4,320. And that is over the 15625. If you include the 2/5 and 3/5 in those parentheses, if you include the 5, you get some decimals, and the math answer fraction doesn't always pull it back. So it's easier to leave them separate. Again, the denominators will turn out to be 15625. The top is 6c4, 2 to the fourth, 3 squared. And when you type that in, you get 2160 over 15625. The next one will be over 15625. And that's always going to be consistent. Whatever the number is for the first one, it'll be the same for all of them, because the exponents always add up to 6. So the 5 is always actually being multiplied out 6 times on the bottom. And this one would be 6c5, 2 to the fifth, times 3 to the first. And the last one would be 6c6, 2 to the sixth, 3 to the 0, all over 15625. So I want you to realize, another way to see that, if it helps, is you can do this. You can move those exponents in, and there's your 5 to the sixth being done out separately. That might help you see why they're all like that. You can also type it in and try the math answer fraction. It doesn't work real well, but maybe your computer's better than mine. My calculator's getting old. What do we get for these numbers? Well, this one was 576 over the 15.6. Ooh, that's a 15, sorry. I have these written down so I won't screw up. 625. And the last one is the least likely. To get 6 wins is very unlikely since it's less than half. That is 64 over 15,625. When you add them all, obviously it's over 15,625 since they had a common denominator. And we get there 7120. That is about 46% roughly. All right. So that's a big example. I'm going to go look and make sure it's all in the picture. I think I have it all in the picture. I do, just barely, but I do. All right. A lot of talking to do this. A little easier when you see our next example. I'll get it set up again and we'll go through it. All right. So let's clean this up. For example 2, we're using the same spinner. Still 2 winners, 3 losers, 2 of 5 and 3 of 5. And that was at least, which meant we had to have 3 or more wins. This time we'll be in at most. All right. So, example 2. What is the probability of, at most, what did I have here? 2 wins in 8 spins. At most, 2 wins in 8 spins. Now, at most tells us right away that we are looking for up to 2. Well, let's think about what's going on here, okay? Just the general idea. Lots of ways to approach it, but really out of 8 wins, if there's an 8 total, and we want to have at most, we should start with wins and losses. So you got 0 and 8, 1 and 7, 2 and 6, 3 and 5, 4 and 4, 5 and 3, 6 and 2, 7 and 1, 8 and 0. That's everything that could happen. And there is an expression using the NCR, P to the R times Q to the N minus R for every one of these. And if I did them all, that would be creating my sample space. Those are all the things that would happen. Well, when I look at this list, if you talk about at most 2 wins, that means up to 2 wins. So we're talking about 0 wins, 1 win, and 2 wins. So I want exactly 0 wins, exactly 1 win, and exactly 2 wins. And I'm going to add those up. So my answer in notation form would be this. 8C, we start with 0 wins. My wins will have 0. My losses over here will be in red. There will be 8 losses then. I will be going on then to have 8C1. I want 1 win now, which means my losses are 7. 1 more then, and the last one. Out of 8, I want to win exactly twice. So the 2 goes right there. This number, if you're winning twice, then you're losing 8 minus 2, 6 times. What goes in here? Well, again, it's 2/5 and 3/5. 2/5 and 3/5. 2/5 and 3/5. So what have we got here? Well, what we've got here is a perfect setup. That is the answer in notation format. If you were to type that in your calculator exactly as it is, you would get a very accurate decimal. If you tried second, math answer fraction, it probably wouldn't pull it back. So again, how do we deal with that? Well, 5 to the 0 times 5 to the 8th, 5 to the 1st and 5 to the 7th, 5 to the 2nd, 5 to the 6th. So we're going to come over here and calculate 5 raised to the 8th. And I've done that on my card here. And it is 390,625. 390,625. And that's what the denominator of all of these will be. So my probability could be rewritten this way. I don't really want to write that for each fraction like I did the last one. I'm going to write it once. When we've taken care of the 5s, you shouldn't do this in notes, but once the 5s have all been taken care of, literally, that's what goes on the top. 8C0, 2 to the 0, 3 to the 8, plus 8C1, 2 to the 1, 3 to the 7, plus 8C2, 2 to the 2nd, 3 to the 6th. That's exactly the number of times you would win with 0, exactly the number of times you would win with 1 win, and the number of times you would have 2 wins. All over that. So that's a little bit of a shortcut to avoid the calculator issues. What do these numbers turn out to be? Well, we get, for this one, you can check it out on a calculator. You should probably type one of these in and make sure it's doing what you think it is. I got 81,648. I just literally typed that in, then I edited it to be a 1, a 1, and a 7, meaning I didn't have a lot of work to do. But you should double check that you know how to do all those things, and then 6561. Rather than going back and typing the entire thing in, we like to use the edit. Okay? And that turned out to be, when you put it all together, 123,201. All over 390,625, and the decimal there, I don't think I did it, but it looks like it's less than a third, because 130,000 would be a third roughly. So, planning. Could you make a sample space? Well, if I had 8 spins and someone now asked me for at least 6 wins, it would be boom, boom, boom. So again, if you've written out a complete sample space, that would be very helpful in terms of just grabbing the numbers to answer questions, all right? But we're doing at least and at most, and we're doing mostly as one-offs, so you're not really doing a sample space for homework number 11. This video concludes what you need to know to do all the parts of 11. I've written it, there's a folder in Schoology, there's a picture of the whole thing, and then I've got 4 blow-ups because I wasn't sure if it was readable. The first 2 parts are like from the first video where you're just doing exactlies. the last two parts, those questions are at least and at most. And this is your assignment that you should finish watching videos and do those homeworks by Thursday, Friday, which is, I believe, November, let's see, 2nd, 3rd, 4th, 5th, and 6th. It's all in Schoology for you. Hopefully this makes lots of sense. Combinations are involved, and we're going to talk more about this whole sample space and some really cool math after that. This is Mr. Mistakes saying, good to see you. Fun to be at the board again. And I was here today working with my pals. Would you like to see them? They were right there for me, supporting me the entire way. Yes, Kevin and Buford were here the entire time, giving me good vibes. All right, there they are, right below the peace sign, which I think actually the peace sign's upside down, which I hadn't realized, and has been all year, or someone came in and did it. Okay, that's our video. Over and out from Mr. Mistakes.